Good morning, students. Am I audible?
Yes, sir. Yes.
Okay. So in the last class, we have solved few numericals, okay, related to our energy coefficient, momentum coefficient, and average velocity. So today we are going to solve few more numericals. Okay. And so first we are going to solve this numerical. Okay. What is given? The velocity distribution in a rectangular channel. So in the equation is given as a rectangular channel may be approximated by the equation this. Okay, this is the small velocity, though it is represented by u is nothing but your small v. Okay, your small v. So for small v you have that expression, that is zero point 0.4 plus zero point 0.6 y by y naught. Okay, what we need to find the average velocity, find the energy coefficient and momentum coefficient if y naught is 1 meter. So what is given? It's a rectangular channel. Depth of flow is 1 meter is given. That is your y naught, maximum depth. Okay, 1 meter is given. Okay, and for the average velocity for the small elementary area is given by this expression, that is 0 0.4 plus 0 0.6 y by y naught. Okay, so first we need to find out average velocity. Okay, so we are going to write the equation for average velocity for a rectangular channel. Okay, so that we have already discussed and we have already derived, that is 1 by y naught integration from 0 to y naught, that is the limit, then small v dy. Okay, small v dy. Okay, so now here y naught is given 2 meter, so we are going to substitute y naught is equal to 2 meter. Okay, then we have integration 0 to 2, definitely, because y naught is, oh sorry, y naught is given 1 meter. Okay, so sorry, the y naught value is given 1 meter. Okay, okay. So here limit is also from 0 to 1, 0 to 1. Okay, then in place of small v we are going to substitute the equation. Okay, that is 0 0.4, 0 0.4 plus 0 0.6 0 0.6 y by y naught. So y naught is again 1, so you can directly write 0 0.6 y. Okay, as our the final actual expression is 0 0.6 y by y naught. So y naught is equal to 1, it's given. So we can directly write 0 0.6 y, and then we have dy. Okay, we have dy. So again, if you solve, so 1 by 1, so it's 1. Okay, so now we have to integrate separately as we have addition. Okay, so if we have addition, if we have multiplied, then we bring it out the constant term and then we integrate for y. As we have addition, that means we have to integrate separately. dy plus, as 0.6 is a constant, 0.6 integration 0 to 1 y dy. Okay, y dy. So we have to separate. Okay, we have to do the integration separately as we have addition. Okay, so here if we do the integration in this part, as 0.4 is constant, integration of dy is nothing but your y. Okay, integration of dy is nothing but your y. Then definitely we have limit 0 to 1, addition 0.6 is a constant term, 0.6 is a constant term. Integration of y will be your y square divided by 2. Okay, y square divided by 2. Then we have limits from 0 to 1. Okay, so you substitute y equal to 1 first. You have to substitute highest limit 0.4 multiplied by, so 1 minus 0. Okay, when you substitute the limit, it will be something like that, higher limit minus lower limit. So first y equal to, we have to substitute 1 as the higher limit, then subtract, then we have to submit the lower limit in place of y. So our lower limit is 0. So 1 minus 0 is again 1. So this part will be your 0.4. Okay, plus this will be again 0.6. We have to, so it bring it out, and then we have to substitute the limit. Okay, 1 square minus 0 square, minus 0 square. So 1 square again it's 1. So what is going to left out is, here it is 0.4 and here 0.6 divided by 2. And if you further simplify, if you further simplify, it will be 0.4 plus 0.6 divided by 2. Okay, so if you add these two, you will get 0.7. Okay, as is the average velocity, it will be meter per second. Okay, so this is the value for average velocity. Okay, so here it's given the answer. We are getting the same. Okay, 0.7 meter per second. Okay, so this is 0.6 divided by 2, it's 0.3. 0.3 plus 0.4 is 0.7 meter per second. Similarly, you just try to find out the alpha value. Okay, so for average velocity, we have, just now we have calculated that value is zero point 0.7 meter per second. Next step is, we have to find out alpha, that is your energy coefficient, alpha. Okay, so you write the expression for alpha for rectangular channel, as in the question it's given. So we can directly Write the expression for rectangular channel. Y to, so 0 to y naught integration, then small v divided by capital V whole cube 1 by y naught dy. Okay, 1 by y naught dy. Okay. So here for capital V we have already calculated, that is 0.7. Okay. For small v we are going to substitute this expression 0.4 plus 0.6 y by y naught. Okay. Then we have whole cube. Okay. So if you further substitute the value 1 by y naught, so y naught is equal to again 1. Okay, it's given. So 1 by 1 is 1. So we are not going to write this one. So integration 0 to 1 velocity v cube. So that capital V is a constant that we have already calculated, that is zero point 0.7. Okay, then we have whole cube, don't forget. Okay, we have whole cube, so it will be 1 by 0.7 whole cube. Okay, then we have multiplication integration 0 to definitely 1, y naught is equal to 1 is given, and we are going to substitute the expression for v. Okay, that is 0.4 plus 0.6 y by y naught. Y naught is again 1, so we can directly write y. And then don't forget we have cube. Okay, we have cube, so it will cube and then dy. To solve this equation here, for that before integration we have to break this out. Okay, by a plus b whole cube, we have to consider this term as a plus b whole cube, and then we have to take the expression for a plus b whole cube, that is a cube plus a square b square plus thrice. Okay, so you have to use that expression before integration, and then you have to go for integration. So we have to consider the expression for a plus b whole cube. Okay, we all know it's a cube plus thrice, or you can directly write b cube. Okay, no issue. You can write here a cube plus b cube plus 3 a square b plus 3ab square. Okay, 3ab square. Okay, so this 0.4 is a for this equation. For this equation, this part is a. Okay, this is a. This is a. Okay, and this part is b. 0.6y is b. Okay, then you substitute in this equation here. Okay, after that you have to integrate separately. Okay, after that you have to integrate separately and see your alpha is 1.18 or not. Okay, this value. Okay, try to solve, because it's a little bit difficult to solve here in the screen. Okay, so you do of your own, and if you find any problem then let me know. Okay, we are going to discuss here. Okay, so you take a pen and paper and try to solve. Okay, and find out the alpha value. You are getting 1.18 or not. Okay, but always remember, we have to, when we have such equation, before integration we have to break it up. Okay, by a plus b whole cube, or if it is square then a plus b whole square. Okay, then only we can go for integration. try to solve, okay, and try to find out the alpha value. If you further solve, so this will be your 1 by 0.7, 1 by 0.7 cube, okay. Then we have integration, okay, 0 to 1. So first one is a cube. So first is our zero point 0.4. So zero point 0.4 cube is nothing but 0.064. Okay, 4. Okay. Next a cube. Then we have b cube. B is our zero point 0.6y. Okay. If you cube it, then it will be 0.216 y cube. Okay, y cube. Okay. Then we have thrice a square b. Okay. So if you do that one, you are going to get a result of 0.288y. Okay, 288y, 88y. Okay, y. Then again addition, thrice a square b. It's done. Okay. Next is thrice a b square. So result in you are going to get 0.432 y square. Okay, y square. Okay. Now you have to integrate each and every term. Okay. At last you have dy. Okay, plus you have dy. This is a plus b whole cube. Okay. Now you integrate each and every term. Okay, first you integrate this one. So definitely it depends on you how many steps you need to complete this numerical. Okay, it's better if you take less steps. Okay, because now for exams it's the duration is reduced to 2 hours. But if it is not possible for you, so you take as many steps you want. Okay, but it's always preferable to solve within less steps. Okay, so those steps you can. So these are the steps. These you can neglect. Okay, if you can. Okay, because it also depends on how good you are in mathematics. Okay, so if you are good enough, then you can skip some of the steps. Okay, so if you after integration each and every term, you will get from that integration part you will get 0.406. Okay, 0.406. And then we have a divide because in the starting we have a constant 1 by 0.7 whole cube, so it will be divided by 0.7 whole cube. Okay, and if you solve this you will get 1.184. 1.184. So if you have calculated that alpha, then you go for beta value. Okay, use the expression for beta for rectangular channel and try to calculate the value. Okay, similarly is very much similar to the your alpha. Okay, but here in that beta equation you don't have cube, you have square. Okay, so you have to use a plus b whole square formula. Okay, that is a square plus b square plus twice ab. For beta, as it is given as a rectangular channel, we are going to directly use the expression for beta. Okay, that is y by y naught, sorry, integration 0 to y naught, 1 by y naught v divided by capital V whole square dy. Okay, so here this y naught is again 1, so 1 by 1 is 1, so integration is 0 to 1, capital V we have already calculated is zero point 0.7, so it's 0.7, and we have square, so it will be whole square. Okay, whole square. Okay, and then small v, in place of small v we are going to substitute the expression 0.4 plus 0.6. Okay, as y naught is equal to 1, so it will be directly y whole square. Okay, dy. So now you have to break before integration. Okay, as a plus b whole square. Okay, you have to break it down as a plus b whole square and try to find out the beta value. solve the next problem, that is your 1.2. Okay, so kindly write it down the equation and try to solve at home. Okay, velocity distribution in a wide river of 3-meter depth is given by, that expression is given, okay, for small velocity. Okay, you need to find out alpha and beta. Okay, so definitely if they are you are asked to find out alpha and beta, so to find out alpha and beta we have to find out average velocity first. Okay, then only we can find out alpha and beta. Okay, so you just write it down the question. Okay, and you can also write it down that next question 1.3. Okay, it's a rectangular channel. V by Vmax is given, so Vmax is already given 2 meter per second. Okay? Vmax value is given 2 meter per second. Y naught is also given, that is 2 meter. Okay? Small v is nothing but that velocity in that particular elementary area. Okay, capital V you need to find out. Okay, don't confuse this Vmax and that average velocity is different. Okay, to find out alpha and beta we have to first find out the average velocity. Okay, and you can note it down the answer. Alpha is 1.058 and beta equal to 1.02. Okay. So in the next class we are going to discuss about uniform flow. Okay, and there is also one question. Okay, we have a show that alpha is this equation and beta is this equation, that I will give you as a snapshot. Okay, you don't have to worry, I'll give you as a notes of that derivation. Okay, question was this, that is 1.1, the velocity distribution along a vertical in a rectangular can be expressed by this equation. Okay, v by vmax is equal to y by y naught to the power 1 by n, where n is nothing but your an exponent. Okay, so you can write down this question. The solution of this question I will give you as a snapshot. Okay, or as a notes in your WhatsApp group. Okay, so you just write down this question, that question number 1.1. Okay, the velocity distribution along a vertical in a rectangular channel can be expressed as, you write this expression, that is small v divided by v max is equal to y by y naught to the power 1 by n. Okay, 1 by y naught to the power n. Okay, you can write where n is an exponent. That same question, the other part of the question is, okay, so this is the continuation of your that question 1.1, that so that After that question, we have to prove that alpha is n plus 1 whole cube divided by n squared n plus 3. Okay, this is the continuation of question 1.1. Okay, they have given an expression v by v max. Then we have to prove that alpha is equal to n plus 1 whole cube divided by n squared n plus 3, and for beta is n plus 1 whole square divided by n plus 2. Okay, so we have to prove this alpha and beta. Okay, so don't worry, this derivation I'll give you as a notes. Okay, so in the next class we are move on to the next topic, that is our uniform flow.